afternoon, students. In this video, we will see what is meant by minimization of DFA. Minimization of DFA means we know that DFA is the deterministic finite automata. When you are designing for DFA, it may contain many states. Minimization of DFA means the process of reducing states to the smallest possible amount. That is, the number of states can be reduced. You draw a DFA with 10 states. Without changing that language acceptance, if you can reduce it into 5 states, that's called as the minimization of DFA. The minimization of DFA can be done with the help of 3 different concepts. So the first one is the dead state, elimination of the dead state. The DFA contains a dead state that can be eliminated. What do you mean by dead state? For example, consider the DFA. It begins with the start state and then it goes to the next state. Not this is state T, and this one is state R. And next there is a state. Consider R is the final state, and there is one more state called as S. And for the S, A comma B equal to S, and A and B. When you consider this DFA, there is a path from P to R with by transiting the symbol A. Similarly, from R to S also there is a path for B, but R is the final state. Whenever it reaches final state, the string is the acceptable string. The string A is accepted by this DFA, but B is the dead state because A comma B there is a path to B. Even though there is a path, it will not be processed during the language acceptance. So this is called as the dead state. Same manner, the inaccessible state is also be eliminated during the NFA minimization concept. What do you mean by inaccessible state? Consider this finite automata. Here Q0 comma A it reaches Q1, Q1 comma Q3, there is no path. Similarly, from Q2 also there is no path for Q3. There is a path for Q0 to Q1, Q1 to Q2. Similarly, Q2 to Q1, everywhere path is there. Every state is reachable from the initial state except Q3. Q3 cannot be reachable from the initial state. We know that any state is not reachable from the initial state. There is no meaning for that particular state, and that state is called as the inaccessible state. Then next is the removal of the equivalent state. First, you have to identify which all are the equivalent state. If more than one states are doing the same operation, we can eliminate that state also. That is called as the removal of equivalent state. For the removal of equivalent state, we are using 2 methods. First one is we are using the equivalence theorem, and another one is the Michael-Nerod theorem that we will see in the next class. So in simple words, deterministic finite automata minimization means remove the unwanted states and equivalent states from the required DFA so that we can construct the optimal DFA. The thing is, the language accepted by this DFA can be accepted by the minimized DFA also. The other name for this technique is optimization of DFA. So the language is same for DFA, NFA, as well as the optimized DFA. That's all.